Hello everyone, my name is Shreyash Sharma. Today I'm going to do a seminar presentation on geosynthetic concrete matrices. First, we have table of content. In the table of content, first we're gonna see about introduction, why to use geosynthetic concrete matrices, application of GCCM, function of GCCM, and case studies. Then conclusion. So, moving on towards introduction. What is geosynthetic concrete matrices? A geosynthetic concrete matrices is a specialized construction material used primarily for soil erosion and protection of subsea pipelines, cables, and other infrastructures in water bodies. It consists of flexible and durable geosynthetic fabric filled with a cementitious mixture. Introduction to GCCM. GCCM's geosynthetic cementitious composite mats were defined by ASTM D35 committee in 2017, emerged around 2009 and gained prominence of channel lining in drainage and irrigation projects. Factors assembled geosynthetic composites consist of cementitious layer within geosynthetic materials. Three-dimensional fiber structure filled with dry cement and concrete mix, overlain by a hydrophilic filter layer, underlain by a watertight membrane, typically PVC film, unrolled into place using traditional geosynthetic installation techniques, hydrated by spraying with water, using causing the cement concrete mix to harden. Permeability is influenced by the method of joining adjacent layers. Joining methods vary, including mechanical fixing, adhesive C plants, and heat bonding. Versatile and adaptable to various project requirements, relies on the hydration process for hardening, allowing for ease of installation. Why choose geosynthetic concrete matrices? First is quick installation. Laying of concrete canvas at the speed rate of 200 meters square per hour with just a 3% team. It is up to 10 times faster than a regular concrete methods. It's user friendly, easy to use with portable rolls, reducing the need of heavy equipments. No need for power tools. You can cut it with basic hand tools before it's hardened. It's cost effective. Lower project costs due to the fast and easy installation. One pallet of concrete canvas covers up to 200 meters square, which is reducing the transportation and storage needs. It's environmental friendly, eco-friendly solution with low mass and 95% less material than regular concrete. A single pallet of concrete canvas has the same coverage up to two 17-ton concrete trucks. Durable and resilient. It has 5 times more abrasion resistance than standard concrete, excellent resistance to chemical and weathering, and won't degrade in UV light. Reinforced for stability includes strong fiber reinforcement to prevent cracking and absorb impact energy. Provides a stable failure mode, ensuring reliability. It's carbon saving. More than 60% of carbon dioxide is saving compared to regular concrete for erosion control in the UK. Certified durability. BBA certified British Board of Alignment with a durability exceeding 120 years in erosion control application. Applications of GCCM. First is hydraulic engineering and structures. In this, we have first channel and ditch lining. Concrete canvas is rapidly becoming the channel and ditch lining material of choice for engineers and contractors around the world. This product solution provides a hard wearing erosion control surface for lining, drainage, and river irrigation canals. Concrete canvas is typically used as an alternative to conventional concrete drainage, where vegetated or earthen lined ditches are unstable due to high flow rates, contaminant requirements, or the need to reduce maintenance. Concrete canvas is significantly faster, easier, and less expensive to install than conventional concrete channel. Lining and requires no special equipment. The matting can be laid at a rate of 200 meters square per hour by a 3% team. Second is culvert lining. Concrete canvas can be used to extend the durability of new culverts or upgrade the existing culvert structure by relining the steel and concrete culverts which have degraded due to score or corrosion. This prevents the need for assessed replacement and extend the life of culverts with improved impermeability and flow characteristics. Outfalls. Concrete canvas has been used worldwide as an effective method of preventing surface erosion, score associated with water runoff from culverts outlet, spillways, and other top overtoppings. These are the few visual representations of channel ditching and lining, culvert lining, and outfalls. Second application of GCCM is soil erosion and control. In this, we have slope protection. Concrete canvas is increasingly being used as an alternative to non-structural short concrete to protect slopes from surface erosion caused by weathering, surface runoff, and environmental degradation. In certain applications, concrete canvas can be used as structural slope stabilization by combining it with steel mesh and soil nails. Compared to short concrete, it is typically faster to install, more cost effective, require less specialist plant equipment, and eliminates the risk associated with rebound and debris. Bundlining. Concrete canvas can be used for hard armor capping of earth burns around petrochemical tank farm, mountainous depots, and flood defenses. It typically uses to protect the burnt from environmental degradation, animal damage, improve impermeability, and prevent weed growth. Concrete canvas ability to be installed quickly reduces time on site. The installation speed of bund lining is approximately 800 meters square per day with a six-man crew. There are few visual representations of erosion and sedimentation control and bund lining. Functions of GCCM. First function of BCCM is barrier. To act as a barrier, it prevents and reduces the movement of any liquid through the use of a geosynthetic barrier used to isolate one material from another. Common applications are landfills or ponds to prevent contamination of surrounding area. Contaminant. Geosynthetic acts as relatively impermeable barrier to liquids or gases. Geotextile composite of geosynthetic layer liner can be used as barrier to impede flow of gases and liquids. Also used in asphalt pavement overlays and waste contaminant. Drainage. Geosynthetic can act as a drainage to carry out fluid through less permeable soil, ideal for use in subsoil drainage system, can be used to dissipate porous water pressure at the base of the road and railway embankment, sports field, and behind retaining walls, facilitates surface water runoff. Fourth function, soil and sediment control. The use of geosynthetic to prevent soil and other particle movement on the surface slope acts to reduce soil erosion caused by wind forces, rainfall impact, and other water runoff. The use of geosynthetic in erosion control is to maintain soil cover either as a temporary measure, offering protection from soil loss, wishlist, wishlist vegetation is established, or as a permanent control measure, typically on a steeper slope or high water velocity situations. Protection. Geosynthetic can be acute damage caused by adjacent material, often used together with a barrier to ensure that the surrounding area will not be contaminated. Widely used on landfills, canal construction, and dams. Moving on towards the case study, first case study is from Australia, protecting military bunkers from erosion. Project description. Extreme weather condition in Northern Territory posed a threat to ammunition bunker for the Australian Defence Force. The region experienced high wind, heavy rainfall, exposing to the exposing the bunker to the potential erosion. Maintaining the structural integrity of these bunkers is important as they provide protection for the storage units containing explosive ammunition. Geofibers assisted with providing a durable solution that will protect the bunker from erosion and challenging Australian climate for years to come. Solution. Concrete canvas was recommended for its high strength, durability, and cost effective in erosion protection. A total of 19,000 meter square concrete canvas was installed across the multiple ammunition bunkers to effectively safeguard its erosion. During the installation process, the local contractor meticulously followed the design methodology by ensuring all the edges were terminated and overlapped correctly. Concrete canvas representatives were also present on the site to provide technical support and installation assistance to the contractor, which provides the client with a high level of confidence and assurance in the product. There are other alternatives to concrete canvas available on the market which offer lower strength and cost, but they do not meet the minimum requirements of GCCM standard ASTM 836. Concrete canvas products are regularly independently tested. This ensures product delivered to site will provide the minimum performance requirement as an erosion control solution, mitigation long-term project risk and failure. Case study 2. Protecting slopes from erosion. First, we have project description. A slope supporting critical infrastructure became of concern to the Townsville City Council as it was at a risk of eroding during the coming rainy season. They required an erosion protection solution that would be installed quickly before the Christmas break and the onset of the weather. Shotcrete was considered, but site access limitations made it difficult to spray the entire slope surface and leads lead times meant that a sprayed concrete solution could not be completed in time for the wet season. Solution to that, concrete canvas is increasingly being used as an alternative to non-structural short concrete for the purpose of protecting slopes for surface erosion caused by weathering, surface runoff, and environmental degradation. Minor groundworks Minor ground preparation works were carried out to reduce the potential instability of the slope. Loose materials were removed and major erosion surfaces was filled. Two layers of CC 5th batch rolled were installed horizontally on the slope, while CC 8th batch rolls were then deployed vertically down the slope, secured at the edges and the toes using anchor pegs. All the concrete canvas materials was joined together by 100 overlapping. The temperature at the time of installation ranged at from 30 to 35 degrees and the rain shower hit while the concrete canvas were being deployed. Thanks to the 1 2 hour working time for from hydration, all the materials were was installed and joined before setting began. The installation was hydrated using a supply of water from the storage tank, the finishing touch of an effective and timely project outcome for the client. Case study 3, Protection of Embankment Wall from Erosion. Project description. The South Australian Morgan Water Treatment Plant supplies safe, clean drinking water to more than 130,000 properties through 358 kilometer Morgan to Valley pipeline. During the 1940s, an embankment wall was excavated adjacent to the site, approximately 40 meters long and up to 6 meters high. The steep, exposed face slowly eroded over the life of the water treatment plant, resulting in a client requiring a solution to protect the wall for further abrasion and weathering. Solution to that, the 45-meter long wall was constructed by applying the concrete canvas synthetic composite mats to a steep vertical slope. An elevated platform and excavator were used to sling the concrete canvas into place. Geofabric supplied at 1.5 tons rate spreader bar to facilitate safe and effective installation. Concrete canvas GCCM was anchored at the top of the slope into a trench as recommended in the concrete canvas guidelines, then pinned and backfilled to anchor and restrict downwards movement. During installation, the finished concrete canvas slope was saturated with reticulated water to enable the curing process to occur. The completed project presents a well prepared slope and subgrade, providing a sleek and uniform profile to the finished product. The concrete canvas GCCM solution allowed for minimal excavation and site disruption, achieving a short construction time frame and reduced disruption to the client's operation. Conclusion: Geosynthetic matrices offers a versatile, rapid, and eco-friendly erosion control and slope stabilization solution for the wide range of civil engineering projects. Thank you.